Hello, this is going to Advanced Math 8. In Algebra 2, we're going to be looking at trigonometry and right triangles. So, if you don't remember from your geometry, the ratios of a right triangle side lengths define the 6 trigonometric functions. We have the sine, cosine, tangent, cosecant, secant, and cotangent. Now in geometry, you may have just worked with these three. So remember, if we have an angle here, which is the right angle, we have the opposite side of the triangle, the adjacent side, which is next to the angle, but not the hypotenuse. Remember, the hypotenuse is always opposite of the right angle, and is always the longest side of a right triangle. Now, one way of remembering this is SOHCAHTOA. S stands for sine, O stands for opposite, H stands for hypotenuse, and A stands for adjacent. Now to figure out cosecant is just sine upside down. Just flip the ratio over. So instead of opposite over hypotenuse, it's hypotenuse over opposite. Cosine and secant are flipped over. And then tangent and cotangent, of course, is flipped over there. So we're just doing a flip. So this is just 1 over the sine of theta. This is 1 over the cosine of theta. This is 1 over the tangent of theta. So it's just flipped over. Alright, example 1. Evaluate the 6 trig functions of angle theta. So what you want to do is you start looking at where your angle is. So it's right here. So we're going to go label our sides. So we go to the opposite side of the triangle and label it opposite. And then it looks like the hypotenuse is already labeled for us, but it's opposite of the right angle. It's the longest side. And then we have the adjacent side. So they want us to find sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. So remember, these are all just ratios, and we need to find out what the hypotenuse is before we continue. To find the hypotenuse, if you remember, is the Pythagorean theorem. A squared plus b squared equals c squared. C squared always being the hypotenuse, in which a and b are the legs of a right triangle. So I have 8 squared plus 15 squared. We're going to see what that equals, which is 64 plus 225, which is 229 equals c squared. Take the square root of both sides, and we'll get a c value, or a hypotenuse, of 289. Square root of 289 is 17. Okay, sine of theta is opposite over hypotenuse, which is 8 over 17. Cosine is adjacent over hypotenuse, which is 15 over 17. And then tangent is opposite over adjacent, which is 8 over 15. Okay, cosecant is just sine flipped over, so 17 over 8. Secant is cosine flipped over, so 17 over 15. And then cotangent is tangent flipped over, 15 over 8. Example 2. If theta is an acute angle of a right triangle and cosine of theta is 7 over 10, what is sine of theta? So they tell us, so let's just go ahead and draw a right triangle. Here's theta, here's a right angle, and they tell us that cosine, so here's opposite, here's the hypotenuse, here's the adjacent side. So, had to pause the video. Okay, so yeah, we look at theta, and we label our sides. And they tell us that cosine of theta, and remember, so that is 7 out of 10, but remember this is also adjacent over hypotenuse. So my adjacent side is 7, my hypotenuse is 10. So we need to find the length of the opposite side, and we're just going to use a squared plus b squared equals c squared. Now remember, our c value is our hypotenuse, so I'm going to have a squared plus 7 squared equals 10 squared. So a squared plus 49 is 100. We're going to subtract 49 over, and we'll get a squared equals 51. So the square root of 51 is some number. Now you can put it into a decimal form, or you can leave it as is, because sine of theta is opposite over hypotenuse. So that is the square root of 51 over 10. And that's your answer. Square root of 51 over 10. Special right triangles. So we had, from geometry, we had the 30, 60, 90 triangle and the 45, 45, 90 triangle. They all have special ratios. And it went like this. If this was x, then this would be double. And this would be square root of 3, x times the square root of 3. Now, what if we had a radius, or if x was 1? We would have 1 here. This would be, let's use a different color. This would be 1, this would be 2, and this just would be the square root of 3. If we wanted to find sine of theta, so in the case sine of 30 degrees, let's use a different color. So if we're looking at 30 degrees here, okay, this would be opposite side, this would be the adjacent side, and this would be the hypotenuse. Sine is opposite over hypotenuse, so 1/2. Cosine would be adjacent over hypotenuse, so square root of 3 over 2. Tangent would be opposite over adjacent, so this would be 1 over the square root of 3, but remember we don't like having square roots in the denominator, so we multiply both top and bottom by square root of 3, and we'll get square root of 3 over 3. Cosecant, remember, is just the sine flipped. Secant is cosine flipped, so we get 2 out of square root of 3, which is 2 root 3 over 3. And then cotangent is tangent flipped, which is just square root of 3 over 1, which is square root of 3. Okay, looking at the 45-45 special triangle, remember we have the two legs being the same, and the hypotenuse being the leg times the square root of 2. So if x was 1, we would have 1, 1, and square root of 2. So sine of 45, you can take either 45 degree, it'll be the same, which is 1 over the square root of 2, which is square root of 2 over 2. Cosine, same thing, square root of 2 over 2. Tangent is 1 over 1, so 1. And cosecant and secant would be square root of 2 over 2 flipped, which is square root of 2. Square root of 2. And tangent flipped over is still 1. 60 degrees. Let's take, I guess, this brownish color. So I'm looking at here now. So that would change this side to be the opposite. That would be the adjacent. And this to be the hypotenuse still. So sine and cosine are just changing or swapping with each other. So this is square root of 3 over 2. This is 1/2. Tangent is going to be square root of 3 this time, because this is 1 over, or this is going to be square root of 3 over 1. Cosecant and secant are going to switch. So this is going to be 2 times the square root of 3 over 3. And this is going to be 2 over 1, so 2. And then cotangent is going to be square root of 3 over 3. So if you memorize this chart, it'll make things quicker. But let's take a look at some of these examples. And you know what? I'm going to, So opposite of the 45 degree angles are the same. So if this is 13, then this is 13. And this is 13 times the square root of 2. Okay, if this is 60 degrees, then this is 30 degrees. So according to our pattern, this is going to be double whatever x is, the hypotenuse. This side here, opposite of the 60, is equal to x times the square root of 3. So 4 is equal to that. So x is equal to 4 divided by the square root of 3, which is 4 root 3 over 3. So if x is 4 root 3 over 3, then double that. Y is 8 root 3 over 3. Solving a right triangle means to find all the side lengths and all the interior angles. If a triangle is not a 30, 60, 90 or a 45, 45, 90, then we have to use sine, cosine, and tan on our calculator. Make sure your calculator is set in degrees. So example 4, we want to solve the triangle. So first thing we want to do is find the missing angle here, and I'm going to call it Z Okay, Z is, so remember in a triangle, any triangle, there's 180 degrees. So I'm going to do 180 minus 90 minus 56. And we'll get 180 minus 90 minus 56 is 34 degrees. So my Z value is 34 degrees. Okay, now we need to find B and C since we already have A. So what I want to do is use the angle that are given to us. And we have label our sides. This is the opposite of the 56 degrees. This is the adjacent side. And C is the hypotenuse. So, using SOHCAHTOA, we're going to look for one of these will help us find our missing side lengths. Sine, for example, is opposite over hypotenuse, so that's B over C. Since we don't know either of those, that can't help us. So we need to use something that we do know, which is the adjacent side. So I'm going to use cosine of 56 degrees is equal to adjacent, which is 13, over hypotenuse, C. I'm going to multiply both sides by C. So I have C times the cosine of 56 equals 13. Now I'm going to divide both sides by cosine of 56 to get C by itself. So I have now C equals 13 divided by, press cosine button, 56. And then you should get approximately 23.25 for your hypotenuse. To find my opposite side, let's go ahead and use a different color. I'm going to use tangent of 56 degrees because that is opposite, which is what I'm looking for, which is B, over adjacent, which is 13. This one's going to be a lot easier because I just multiply both sides by 13. So I have 13 times the tangent of 56 degrees equals B. So B is approximately tangent of 56, which is about 19.27 units, whatever the units may be. .27. Angle of elevation is the angle created with your line of sight and the ground. An example here would be, like, here's U. And let's say you're looking at a building. And we have some windows. But here's U. You're looking upward. This would be the angle of elevation. Angle of depression, let's say you're on a mountain. And this is you up here. And you're just looking out on the horizon. And let's say here's your slope. You're about to go down skiing or snowboarding. So this would be your angle of depression. So either you're skiing down a slope or you're on top of a building. And you have a ramp going down. That's your angle of depression. Hopefully this helped you out. Have a good day.